part 3 or 4, and let's head to the studio and take a look at where we're up to. Here we are. What can we do here? I've got some music playing in my headphones, but it's just become a little bit loud. Is there anything I can change on here? That's better. Okay, so we're using the NACT library, and I've re-implemented the stats collection part. So I started with a project that we had running in a Lambda. Let me just make sure I'm not going to leak any secrets. 1 second. I'll switch here. No, we're good. So let's go right half with my new project, written using NACT. And over here on the left is the original project. Using the actor model, save, I guess. Let's close everything. Open editors. Start with a clean slate. Allow that. Allow. Okay. So here on the left, I have the original project. Left half. The original one was written by Cornelius. It's great. Very well architected. Here on the right, I have my new version written using NACT. The original motivation for rewriting it is that the original one is deployed into AWS Lambda using serverless, and it stores the configuration data as secrets, and it runs on a timer, and it's a little bit difficult to maintain because debugging, logging, it's in someone else's infrastructure. We want to run it just in a VM where we can, log in, mess around with things. It's kind of good once you get it really working and everything down, and then just bake it into something that's scalable, low maintenance, low cost, like a Lambda that runs on a schedule. But we want to extend this. We want to add new things to it. If it doesn't work, we want to be able to log in, debug it. It runs once a month. So if we have to wait for another month for a fix to, we've had an issue with one of the forums that we scrape not working, and okay, I think I fixed it. I think I did the thing, and then you need to wait another month for it to run. We have a staged version in the Lambda, but even then it's difficult to debug because of the logging. So we're just going to put it into a VM. So I took the opportunity to rewrite it, re-architect it. I wanted to try the NACT library, which is an actor library, using the actor model that's used in ZB itself. So this was a very small scope project to do it on. And I also wanted to change the separation of concerns. Let me show you how. Let me give you a run through of Cornelius's original one, full screen. So we have the handler function here, which is an AWS Lambda Hamda function, Lambda handler. So it takes the event, comes in, and we just generate last month as the range, and then here we have the crawlers, and this is the classic, an array of asynchronous tasks that may, any of which may succeed or fail. So in order to add, so you can see here we've got like a discourse crawler, and then we have to bake in, the Camunda forum, the ZB forum, the BPMN IO forum, and then we have the npm stats crawler, and then we're getting the BPM.js, the ZB node. That's it. And then we're waiting for promise all settled. We reduce across them to get the results. Reduce rejected. You could actually do that in a single reduction. But that's okay. And then we write the results into a spreadsheet. So we create any missing tabs, load the info, and then we just add a row. very easy. This part here I haven't implemented yet. But I implemented this first part here where we have a couple of different crawlers and we can crawl different targets. I implemented it slightly differently. Rather than using a promise all settled, I went with the actor model. So we dispatch a message to an actor, which does the thing, and then dispatches a message back saying either result or exception, error. So there's no need to do the reduction. The kind of reduction happens over time through the state of the actor. The only thing about that is that when we do promise all settled, as we do here, await promise all settled, we don't have to manage the machinery of the promises settling. But I had to manage the machinery of that inside, so I'll make this left half, in the stats collector. So here's my stats collector code. And in my stats collector code, looks very similar at the beginning. We generate the range. Let's copy paste the code here. So if we get a query message, we generate the range. And here you have an array of crawlers. Rather than having an array of crawlers, we just kind of like a side effect, dispatch a message to the actor. This piece of machinery here, you can see that this is quite dynamic and generic. Whereas over here, we have to hard code, the exact crawler that we're calling, and then we have to pass in, parameters that we demarshal from the environment. The approach I've taken here is that the actor name is named after the configuration key. So if we have a look at the config, we're going to scan for a number of npm package downloads, and that's actually the name of the actor that does this query. The rename function is common to all of the actors, but this other part here, which could be any number of keys here, is an actor-specific query parameters. So the actor implementation is responsible for reading these queries, which just get passed through to it, and then doing whatever it needs to do. And then it's going to dispatch a message back here, which is going to be of either result or error. Now, in order to isolate the machinery of the actor from people who want to implement, including myself, who want to implement new actors in the future, what I've done is I've created a generic function called makeActor, and what it does is it takes a function that takes a query, so it takes that query, and it returns a promise. And then in here, I chain onto that promise, and then I take care of the dispatch back to the stats collector. So the actual implementation itself of the npm actor, for example, if we have a look at the npm actor here, and we'll have a look at the npm crawler in here. So here's your npm crawler, and here is your npm package downloads actor. So you can see that here we have quite a complex signature, whereas the signature for an actor is just a message. And that message has a range and a query. So the start date and end date come from the range, and whatever is necessary here comes off the query. The renamer function has been lifted out of the crawler implementation or the actor implementation into the actor machinery. So if we have a look at the actor here, the renamer machinery is handled inside here. So in your implementation, you don't need to touch that. To go back here, what we're doing here is we synchronously await the response from npm. We then generate for date, const date. I think what comes back may be like a day by day or a week by week. So anyway, it adds it all up, and then here returns the renamed result. Here we await the return from Axios, and we do it in a then rather than using async and await, because that allows this actor to act in parallel. If we put await inside this actor, it's going to run in series, but it will here return this promise, and then it's available to take another message, because it's what the actor does here is it constructs a promise machine and returns it, whereas this crawler implementation here does the thing and returns the result. This returns a promise of the result. So in the then, we sum all of the data, and then we return the result. So we return a promise of a result, and then when this gets consumed by the actor machinery, it'll take that result and dispatch it back to the stats collector actor with the renamer function called in here. And if there's any kind of error that takes place in this actor, like we get an error in this function here when we're processing the data, or we get an error while we're calling the URL, that'll get caught by this catch here, which will then dispatch an error kind of object back to the stats collector, letting it know that it's an error. And here we reduce the results and errors, merging them into the state as they come in, so they're collected as they are dispatched by the actors. And we have an expected number of outcomes that we're waiting for. And when we get the expected number of outcomes, we then dispatch the complete report to the reporting actor, which is going to do the writing into the Google Sheet. Now, one of the implications of doing it in this, it's a more generic way that I've done it. Here you can see, rather than a concrete implementation of exactly which things we're going to do, where basically the configuration and the implementation here are what would you call that, interleaved or collapsed together. Here I've extracted the machinery of it, used the actor name, which means that, as you can see here, we're like, get this one, get that one, get that one. In the configuration here, it's configuration driven. The actual actor is specified here, and so I can add more packages, more packages, more packages. Like actually we can add the packages that it looks for. BPMN.js is the other one. So rather than NACT, we look for BPMN.js, and then we're going to rename it to BPMN. One thing I looked at here was that, this actor could actually encode that it renames downloads to the package name -downloads, because you can see that that's a repeated pattern. Let's actually see if that's possible now. So if we go into the npm actor, let me bring up my chat window in case anyone wants to chat while we're doing this. Restream.io chat. So Restream.io chat can stream chat from both Facebook. I'm streaming on Twitch and YouTube right now. Okay. So let's see if we can extract it out. Here's the npm actor. Okay. Yeah. Now, because I've lifted the concern of renaming into the actor wrapper, it's a concrete renamer. We could lift it out. if I lift it out of here, what I would do is I would just return message. I would just return result. And then I would put the renamer function. I would just actually create a renamer function here. I would create it here. So I would do this. Const renamer equals. So I use the renamer factory. And then I have to pass in a renaming mapping. So I would do this. Downloads gets renamed to the package name dash downloads. Is that the, yep, that's the pattern that gets used. Actually it doesn't, because if you see the BPMN.js, it actually takes out that minus, so yeah, let's leave it the way that it is. Could genericize it even further, which would make it easier to add more, because then we wouldn't need to add the rename function in here. The downside of that would be it wouldn't be immediately, well, no, it wouldn't be immediately obvious to how to users who are configuring a new package how the renaming takes place. It would be a bit more magic. Let's leave it like this. The other issue with making it generic like this is because the configuration is in a JSON. Actually, rather than making it JSON, I could make it an actual first-class JavaScript object, which would mean that we could go, let's change it to, rename this to config.ts, like this. And then here we would say export const equals const config equals this. Now it means that we can actually, I'm just going to copy my discourse configuration, so I'm going to block the screen for a second. Config private JSON. Discourse forum stats. I go back to config ts. Like that. Okay, so this is really the only piece here that I need to change. And then let's come back from the secret. So I can replace secret keys. This is BPMN IO forum API key, like this. So this way I don't have to put the secrets in plain text inside the configuration. So if we're going to do that, we should pnpmi.env. It's actually on my card for this epic, is how to handle the secrets. Like, where do we put the secrets? We're going to deploy it into a VM using Docker probably. How do we bake the secrets into this thing? Getting them from the environment is a good way to do it. But rather than demarshalling them in the code, we'll demarshal them in this configuration object. I've basically just taken the code that Cornelius wrote and just dried it out to one more level where, you know, you can see that using the DRY, the do not repeat yourself principle, that we've repeated the same thing twice here, 3 times, repeated it twice here. Now this only really emerged as the pattern once we started to modify and extend it and say, well, we want to check another 2 discourse forums. We want to get another package. So when he did it for 1, made sense. Once we did it for 3 and then 2 here, it was like, okay, there's something repeating here, we can dry it out. And then once we can dry that out, can we dry out the overlap between these 2 actors so that we can extend it with a 3rd actor in the future to collect other types of stats? So if we now go into app. I think I just opened my private one for a second there. That's cool. So the first thing that we should do is we should hydrate the environment from a .env file, which I can keep out of get. So .env. So I think you can do it like this. Require .env. Yep. Dot. And then you call configure. Config. Let's see if that's it. Go to the definition. Nope, is it configure? Maybe? Go to the definition. No definition found for that either. Okay, so we'll do it like this. Const. This will hopefully trigger sufficient IntelliSense for us to be able to explore the API. Nope. Where is the semicolon on this layout? Strange. There. That's right. Okay, so .env. Any. Okay, so with IntelliSense we can say convert it to import. Okay, good. So maybe it's called config. Yeah, it's called config, like that. Here we go. So our process environment is now hydrated from a .env file if we have one. Which means that when we require in that case, the way we should do this is we should put this into the actual config. Like that. Dun dun dun. Software. How did this song get into my liked tracks? This is unlike. Next. That's a weird one. That one too. Okay, so we hydrate the environment and then we can process things like this. Let's move this over here. API user, key. So I might try, let's go all out. Let's just do all 3. So discourse settings. Yeah, we'll just put only the API key. Actually, we'll put the user into the environment as well because, you know, that could change. And if it does change, it's going to change along with the API key. So this is less about making it a secret and more about it's likely to change at the same time. So you change it in one place rather than having to change both at once. Okay. So I can just copy this, and then we're going to do, so we do 3 of them. One thing about this is that I liked that it was JSON because it meant you didn't need to recompile the app to you didn't have to recompile the app. I'm just thinking at the moment because we could make it reconfigurable without even having to redeploy or restart the app. And the way to do that would be to make the stats collector actor, when it receives the message, query a configuration actor which reads the file from the disk. At the moment, and this is where the actor model really comes into its own power, is at the moment, in order to reread the configuration, we're going to have to redeploy the app and then restart the app. And because we're now making configuration in code rather than like in a pure config file, it's going to need to it's going to need to rebuild the app. But there is a way to design it, especially using the actor system, where it can continue running, and then you can send a message to it and it will just reread from the disk and keep going. That's the whole thing about the actor system, is like zero downtime. Well, not zero downtime, but when Ericsson rolled out their Erlang system using the actor system, they went to like 6 nines of uptime. 9 nines, something like that, some ridiculous thing. So that's how the actor system has gotten a great name. So might as well lean into that. And if we're going to go with the actor system, we'll go all the way. We'll make this thing like it just runs forever. It runs forever once a month. You know, it's the kind of application that you would start it using a cron job and it would just run and then stop, rather than just sit there running continually forever for once a month. It could be run using Docker run and then, you know, mounting a config file into it, and then it runs once and then exits. That would use less resources. Wouldn't leak for sure. So it might be overkill to design it to, you know, reread its configuration from the disk. However, requiring a recompilation of the requiring a recompilation of the code. So again, I've gone back with this approach of moving out of the JSON to a config TS. I've gone back to this. Okay, I'm going to think about this. I'm going to think about this for a couple of minutes. I'm going to grab something to eat, think about this, let my brain think about something else, and see what I come up with. I will be back.